One of the most notable of recent events that involved fire and smoke was on a Boeing 747 that crashed attempting to land in Dubai in September 2010, and we'll hear more about that in a moment. Although much work has been done in recent years to equip today's airliners with advanced fire retardant materials, sufficient firefighting capability, and breathing protection, incidents still arise that require the crews to diagnose smoke or fumes in the cockpit and take immediate steps to land the aircraft. What actions are the airline industry and regulators taking to ensure that cockpit emergency equipment standards are up to the task of today's aircraft smoke and fire threats? I have with me today Captain Boomer Bombardi, project leader for ALPA's in-flight fire project. In this capacity, Captain Bombardi is responsible for developing ALPA policy related to mitigating smoke, fire, fume events and the corresponding flight crew and aircraft requirements needed to ensure safety of flight. As a former C-141 pilot for the U.S. Air Force, he first became involved with in-flight fire in 1984 following the loss of a C-141 crew due to smoke in the cockpit, culminating with the rewriting of Air Force C-141 smoke, fire, fumes procedures. Mr. Gus Sarkos is the manager of Fire Safety Branch at the FAA Technical Center, which conducts the FAA Aircraft Fire Safety Research and Development Program. Over the years, numerous research projects from this program have been implemented throughout commercial aviation by regulatory or advisory material, resulting in significant improvements in post-crash fire survivability and in-flight fire and fuel tank explosion prevention. He has over 45 years of experience with the FAA in conducting or managing aircraft fire safety research and development. Captain Bill Reed is a Boeing Flight Operations Testing Evaluation Safety Pilot and Accident Investigator. He has more than 20 years in commercial aviation and experience in both simulator and airplane flight training at Boeing. Bill has also represented Boeing as an operations group member on numerous commercial airplane accident investigations, including the most recent UPS-6 and Asiana 991 investigations. He has also worked on various internal Boeing initiatives relating to onboard fires. Currently, Bill flies the 737, 747, 777, and the 787 for Boeing. And our final panelist, Captain David Lawrence, is a senior aviation safety investigator with the National Transportation Safety Board in the Operational Factors Division. He is a retired airline pilot with over 30 years of experience in line operations, training, safety, and accident investigation. With the NTSB, he has been involved in numerous accident investigations worldwide, and specifically was a U.S. Operations Group Technical Advisor on the UPS-6 in-flight fire accident in Dubai, and assisted the Korean government with finalizing the ICAO report on the Asiana 991 in-flight fire off Jeju Island in South Korea. He is also an author of numerous smoke, fire, fumes related safety recommendations adopted by the NTSB. So let's get started. And my first question is to Captain Lawrence, that you were involved with that accident investigation done, the UPS-6. Can you kind of give us an overview what that event entailed and what we learned from it?
Thanks, Bill. Yeah, I think to start with, I know a lot of people are familiar with UPS-6, but maybe give it a 30,000-foot review level, just a review of what happened and how the NTSB got involved with the UPS-6 accident. Obviously, September 3rd, 2010, 747-400 departing out of Dubai on its way to Cologne. The aircraft was actually inbound from Hong Kong with a high load of ULDs that were and palletized material that was containing lithium batteries. They took on an additional load in Dubai. The crew was on a overnight in Dubai, so this was their first flight of the day, and they're going to fly the airplane on up to Cologne. Aircraft departed normally, 22 minutes in flight at an altitude of 32,000 feet. They got a main deck fire warning, began their fire main deck procedures through the QRH. About 2.5 minutes after the alert came in, the fire main deck alert, there's evidence of compromised flight controls. 3 minutes after the fire alert, so that's just another 30 seconds after the controls were compromised, the smoke was filled with smoke that was, both pilots were unable to see the radios, the mode control panel. They were not able to see any of the PFD or the nav display. The crew elected to make a return back to Dubai, and at some point during the time they were on their descent down to 10,000 feet, the captains oxygen system was compromised, and in an effort to get additional oxygen, he removed himself from the seat, and at that point in time, we never heard from him again. And the first officer was flying the aircraft solo from that point on. Aircraft returned to Dubai, but there were control issues with him trying to slow the airplane down. As they came across Dubai, they were about 4,500 feet, doing about 340 knots, trying to give, ATC was giving them vectors over to Sharjah as an alternate, since they couldn't make Dubai. Aircraft made a right turn and crashed in his Army base that was basically a deserted Army base. No fatalities on the ground, 2 fatalities in the actual airplane. So that was just the overview of the actual accident. How did we get involved? Well, under Annex 13, obviously as the state of manufacturer, state of operator and stuff, the NTSB was involved in that accident. We launched a full go team to go to Dubai. We had human performance experts, myself, operations. We had a U.S. accredited rep that went, and fire experts, systems and power plants, and structures experts that went. Our primary goal, and I want to emphasize this too, it is not our accident and it is not our report that came out earlier this year. We were there to assist, but obviously we had a full team of experts to assist them. In the course of the operations investigation, we did numerous testings. We went up to Anchorage, Alaska in the UPS 747 sim where they did their training and did numerous testing up there for procedures, fire main deck procedures, and looked at use of the oxygen mask. I'll get to that in just a second. Then, in addition, we went to Seattle, and in a 747-400 simulator there did additional testing with visibility restriction. We had a smoke generation system in the sim and ran the same accident scenarios now with smoke generation and visibility restrictions. Some of the things we learned from the testing in the simulators were assumptions that pilots make about their knowledge and use of the oxygen masks. I know we've all seen these, we've all have experience with these oxygen masks, and we tend to use them quite regularly. But in the confines of a smoke-filled environment, it is very difficult to anticipate what you will do and what you need to do with a smoke environment with the oxygen masks on. We found some things. Some airlines and some operators have simulators that they train in that have smoke generation systems, and usually it's just a wispy smoke that comes down. It's usually just to trigger the pilot to get into the checklist and start using the checklist. The smoke generation visibility restriction test we did in Seattle, we're trying to simulate visibility restrictions. However, what we learned in UPS and what we've also learned in some of the wreckage recovery that we've done in Asiana 991 that crashed off of Jeju Island is that when you see smoke and you see smoke that's this white type of smoke and it looks like a visibility restriction, that's not what's happening on some of these accident flights. That's not what occurred on UPS 6 and it did not occur on Asiana 991. We have physical evidence that says that the smoke is not this white, theatrical, nice little smoke. It is black, sooty, particle-filled, toxic. It is the most unimaginable type of environment. So it is not just a wispy smoke that you can look through. It is completely debilitating in the cockpit, and it happens rapidly. We saw the video this morning. Everybody see that video when they had the little side shot of the FAA test that showed the cockpit and how it filled up? Multiply that by 10 with a visibility restriction is what we're seeing in some of these cases. The recommendations that came out of UPS 6, the operational related ones, were because we saw during our testing that pilots, when we asked them to don the masks and proceeded with the procedures to deal with the smoke fire fumes, they have difficulty sometimes. You heard earlier today that UPS 6, or UPS as an airline, they had the old Aeros oxygen mask plus a smoke goggle, so there was a multiple donning time that was necessary for that. We saw time delay in getting into the checklist because they were having problems doing that, so we wrote a recommendation basically that said we need to do full face masks for everybody. And the time has come for that as well. There was a 1978 study that the FAA did on masks, and some of the difficulties in donning masks were documented back in 1978. So the time had come that we need to see all operators in the 91K, 135, and 121 environment having full face masks. The recommendation was out there. It is still open. The FAA has right now said that they don't see a need based on accidents and incidents that they have in their database. So that recommendation is still out there. There was another recommendation that we came out from UPS 6.2 was to do tactile training on the oxygen masks. We have all been in the simulator during the course of our careers where you are taking a recurrent training or something and the instructor will lean forward and say, okay, we're going to do the high dive depressurization from 20,000 feet or something, or we're going to do the smoke fire fumes and get you to use the checklist. I know you guys know how to use the masks. Don't do that. We'll just concentrate on the procedure. Everybody hear that once or twice? That is a disservice to your training if you hear that. And as operators and as pilots, what we should do is insist. Now, I understand the check airmen and instructors are trying to do the right thing. They're trying to be good guys. But by doing that, you're losing the ability to practice the tactile feel of how to use one of these masks. You may assume that you know how to use this, but until it is the time that you have to do it, you'll never know how you respond. Opportunities to train in recurrent, opportunities to practice this. We all do this to use the mask about 25,000 feet when the other one gets out to take the bathroom break, right? Right. Use that opportunity to understand the mask, because the title of this forum, this panel right here, says when seconds matter. And I cannot emphasize more than what we've learned from UPS 6 and what we learned from Asiana and some of the other smoke, fire, fumes events that the NTSB has investigated, is that you don't have that much time. It is seconds before you will be debilitated in the cockpit, and you can't do those things like aviate, navigate, communicate. We all say that, right? Okay, the first thing I'm going to do is aviate, and the second thing I'm going to navigate, and then I'm going to communicate, right? You can't do any of those three things unless you protect yourself. And you have literally seconds, and you may only have one chance to do it right. Only one chance to get it right, because if you don't, and we found this out in UPS 6 too, through a lot of analysis in the CVR. We also did a sound spectrum analysis on the CVR to determine what the masks were actually set at, and found out that the captain had originally set his mask to 100%, as it was required by the smoke, fire, fumes checklist. First officer had his mask at normal. And everybody knows that these masks, if you're in normal, as you go down to lower atmosphere, you're now drawing in a little bit more ambient air in the mix in the mask itself. And I just told you what that environment was like, so you can tell what's going into that mask as well. So all these things, the training, the tactile feel, all these things we saw as a need to issue safety recommendations in advance of the Annex 13 report. We did these about 1 year and 10 months after the accident in advance of the UAE report, because we thought it was important enough that pilots need to know you need to train properly on these masks. You need to insist that these masks are full face masks, because these old Army surplus goggles and stuff like that just don't cut it. You need to understand the mask. Everybody know how to use a vent? To vent the smoke out of your eyes? A lot of people didn't even know, some of the people we tested didn't even know that vent was even there. So we wrote recommendations that were operationally related to the masks. We also, in addition, how many people have heard this in the simulator? You don the masks, you've done everything you can, you start reaching for the panel button, and can you hear me? Can you hear me? Can you hear? Can you hear me? You know, there's more to operating the mask than just inhaling. You have to learn how to operate the mask and be able to communicate with the other person, because you may not be able to see the other person in one of these environments. And the audio control panel for some of these airplanes are completely different. We all transition to different aircraft. Many airlines fly different fleets and such. The audio control panel is completely different. You need to train on that audio control panel with the mask on. We don't have that in 121 training. So The whole gamut of this, we learned that there needs to be additional recommendations that go out to the FAA for additional training, more tactile training, more concentrated training on how to use the mask, how to operate the mask in the smoke-filled environment, and how to operate it with the audio control panel, because it's important. We have a two-pilot environment. Pilot flying says, okay, I'm gonna fly the aircraft. Pilot monitoring, you run the checklist. Now we're filled with smoke, we got our masks on, we're trying to use an audio panel to talk between each other. You got a checklist, the pilot monitor's got a checklist. Now he's reading the checklist while he's communicating down here, and he has to do buttons up here. And what we saw sometimes is people having to put the checklist down so they can operate and manipulate an overhead button and try to communicate at the same time. I mean, it's a little bit of patting your head and rubbing your tummy at the same time. If you don't practice this, as pilots, you don't insist that you see this in your training. You need to insist that the operable mask is available to you, either in an FTD or in a full flight simulator. That's your responsibility and the operator's responsibility. And that's where some of the recommendations came out of UPS 6 that were operationally related.
Thanks, David. To go along with that, I mean, when I read the report, I took that advice, and you know, when you leave the flight deck, the other person dons the mask. And in my airplane, it is a separate mask and goggle arrangement. And I had forgotten, I'm thinking, okay, this is a smoke-filled cockpit. And I had forgotten, for me, we wear headsets as well. In order to get the smoke goggles on, I got to take the headset off, get the mask on, then there's an order of events. And I'm thinking, you know, this is a really good idea. It's not just practicing putting on the oxygen mask. If you have a separate goggle arrangement until we can get full face masks, at least my recommendation is, along with yours, is to occasionally go the 9 yards, look like Darth Vader when your flying partner comes back into the flight deck, but go the whole 9 yards, put everything on, make sure you can get communications established, because in the heat of battle there, of course, you got acrid smoke potentially in the flight deck. It's a stressful situation, and this needs to be automatic. And same thing with the vent valve. I remember I knew about it, but I had to, okay, I can't tell how is it open or closed when I have it on my face, so I had to take it off and look. You know, it's as I said before, there are no small jobs in aviation. It doesn't seem to matter. They're quite complex. So thank you. Captain Bombardi, Boomer. Can you go ahead and give us a little bit of a synopsis just on the current ALPA policy that we have in play?
Sure, no problem. Before I start, though, I'd like to just piggyback on what the General said this morning as far as Gus Sarkos and the FAA Tech Center in Atlantic City. These guys are the unsung heroes of the safety profession, and there are airplanes flying today, and there are people alive today because of the work these guys do down there. And Gus, from the guys who fly the airplanes every day, thank you to you and your guys for what you've done to keep our industry safe. Yes, definitely. Unfortunately, Gus doesn't set policy. Gus is the instrument of policy changes. And we've come a long way in the last few months and years. The gentleman to my right here has done a great service to us by putting into words what we really need. We need the ability to know where the fire is on the airplane, the nature and intensity, and do we have control over it. We need to be able to see to fly. It's no good to have the back of the aircraft nice and clean, but the front of the aircraft in the cockpit, I can't see out to fly. We've quantified that. We've put it in wording. The policy is there. It's great. It's what we need to say. Unfortunately, ALPA does not set policy. Unfortunately, in the past few years, the people who have set policy and should set policy and regulations have failed to do so. Prior to value jet, cargo compartment fires were always said to be too expensive. They'll never put it in. Value jet augers went into the swamp, and the next day we have cargo compartment fires. Can you put the screen up that shows the regulatory initiatives and policy changes for determining the nature and intensity of a cabin fire? Do we have that screen? No, we don't, because there is none. How about the screen that says, how are we going to keep the cockpit from getting smoke into it and keeping the environment so the guys can see? What regulatory policies have come out for that? Do we have a screen on that? No, we haven't. UPS 6, that airplane flew for 23 minutes. 23 minutes that airplane was flying, and that first officer was doing the best he could to try and get it on the ground, but he couldn't see. You give me 23 minutes, and I can see my instruments, I'll have the airplane on the ground, I'll have the passenger safely off, I would give an interview to Fox News, I will be in your local establishment having a cold brew and filling out my ASAP report. This guy had 23 minutes, but he couldn't see. As pilots, we're trained to handle about any emergency out there. Short of the wings falling off the airplane, there's not much that's going to happen on this airplane that we're not going to be able to get it on the ground, except for a hidden fire. When I've got a fire in the back there of unknown intensity and origin, I have no idea. And this morning, the panel brought it out great. You have no idea how long you have. Do I have 10 minutes? Do I have 20 minutes? Do I have 13 minutes? When do I have to get the airplane on the ground? So I'm relying right now on a flight attendant in the back of the airplane to say, there's smoke, I don't know where it's coming from, I don't know how bad it is. If the cockpit fills with smoke and I can't see, we're not going to land the airplane. We have great policy now that says what we need to have done. We just don't have anybody out there saying, do it. And I guarantee you, if the phone rang in the tech center tomorrow and someone told Gus Sarkos, I want you to figure a way to have the crew have just a minimal amount of knowledge on where a fire is in the back of the aircraft, just getting hot and getting hotter, he could do it. I guarantee you, they said, we need to find a way to allow the cockpit crew to be able to see, to fly and safely land the airplane in a smoke-filled environment, he could do it. We just haven't had anybody pick the phone up and give this guy a call yet, and it's long, long overdue.
Thank you, Boomer. Some of the other pieces of the ALPA policy, I mean, he talked about the overarching ones, but include, in particular, last year we advocated for taking a look at continuous generated smoke. Presently, the certification requirement is for the introduction of smoke into the flight deck and having the ventilation system evacuate that smoke. I think it's within 90 seconds after the source has been stopped. There's a recommendation that the continuous generated smoke type situation be considered, but it's not a requirement. And we already have examples here with UPS 6 and Asiana where they were continuously generated smoke. So the bottom line, as Boomer pointed out, as pilots, we need a means, and I'm not going to advocate any particular manufacturer or supplemental equipment provider. From a pilot's point of view, we can just look at the performance-based requirement. We need a means to be able to see the instruments and see beyond the instrument panel to land the airplane. And I don't really care how they do it. FedEx showed a really great idea using head-mounted displays. There's EVAS. There may be other methods out there that we aren't smart enough to come to grips with. Synthetic vision may be one. There may be others. So I think it's imperative. I mean, it's a pretty, you feel pretty helpless when you're in that kind of a situation. You know you can fly this airplane, irrespective of issues that come up with in-flight fire where you start getting compromised controls. But you need to have all the tools available to have the best potential for the best outcome. So
that was a great presentation this morning. In fact, if you're concerned, and I'm concerned about if my family flies next time about a smoke incident, what's happening, I'd consider shipping them FedEx or UPS because these guys have led the way. I mean, look what they've done.
Yeah.
I guess that's going to be the quote of the day. I mean, look what they've done on their own. No one told them to do this. You know, they really did some innovative things there, and it's things that can cut across to the commercial side of the house. You know, their sensors, the cockpit system where you can, you know, if you can't vent the smoke, let me just be able to look through it so I can get the airplane. These guys are great. They're innovative, and I wish someone would pick the phone up and call Gus and said, Gus, let's do it.
Along those, to add what Boomer was saying too, another part of the policy that we added in last year was, and Boomer had alluded to it, was access to emergency equipment while you're wearing your protective breathing equipment. Certainly you can't mitigate a smoke event with the fire extinguisher, but nor should you be in a situation where you have to use the fire extinguisher and wear your oxygen mask and have that oxygen mask come off your face when you just try to retrieve the fire extinguisher. It's our view that if you have a fire on the flight deck, you need to be able to protect yourself, and while keeping that protection integrity intact, you're able to retrieve the equipment you need to fight the fire. And that's something that clearly there's more work to be done there.
Well, it's a great example because we had actual incidents where this happened. This wasn't just a couple of guys sitting around the table going, okay, what's the next thing that could happen? We actually had a 757 that had a history of, the 757 fleet had a history of problems with the transformer heater or something on the windshield, smoking up and doing that. The captain's flying along, all of a sudden his windshield sparks, arcs, flames, smoke comes out, he can't see, gives the airplane to the FO. He gets out of his seat now to go and reach the fire bottle. Well, as he gets out of his seat, his oxygen mask stops him from reaching around. He just barely gets the bottle released, shoots it on the windshield, and they land. The guy says, had it been the opposite, had the FO had to get the bottle and not me, the FO would have taken his mask off in a smoke-filled environment and go do that. A couple months later, we had another airplane, same thing, 7.5. This guy wasn't as lucky. He was pumped up. He had adrenaline going. He's got the fire in front of him. He stands up, turns around, rips his face mask off, and rips his eyeglasses off. So now we're down to one guy in the cockpit. We briefed the FAA on it. We asked for a definition of readily accessible because the FAR say that emergency equipment must be readily accessible. And I'm thinking, there is no way in heck we're going to get a definition out of the FAA on what readily accessible was. Au contraire. In November of 2008, we received a letter from their legal department saying that you are correct. Under the definition of readily accessible, the crew member has to be able to reach emergency equipment from their seated flying position. In other words, if I have to get out of my seat and turn and do something, that is not readily accessible. That was back in 2008. You guys flying home today on 757? Guy can't reach his oxygen, can't reach his fire bottle. 767 can't do it. We say, well, what about the small guys? His airplane, Embraer 145, he can't reach it either. So I don't know how much more you got to do. It's a known problem. It's not something that we're just throwing out that could happen someday. This actually has happened. You cannot reach the fire bottle. The FO can't reach it without getting his mask off. We've actually got a definition that says, yes, it's not readily accessible, but we still have got the problem. So, Gus, did anybody call you up yet?
and to be fair, there are a multitude of things that need to be thought about when you look at trying to relocate emergency equipment. I mean, from our point of view, it seems to be a simple matter, but when the manufacturers have to look at it, it's not such a simple matter. I mean, it's not a simple matter of just putting
put the slide up that right. Came down from some regulator. It says, hey, look into this, and somebody give us a cost on it. Can we do it and all that? Do we have that slide?
And no one's done it. But we're going to do that.
Oh, we are, yes. But we don't set policy. You know, if Boomer set policy, we wouldn't be having this meeting today. It'd be done. Gus would be calling, I'd be calling Gus every other minute. Gus, bail me out, buddy.
Okay, Boomer, thanks. You can sit back now. Gus.
Hey, Lee said shake it up, man.
That's right, that's right. Gus, now the FAA has done lots to improve the situation, and the Tech Center's headed the way there. Could you outline some of those improvements?
Okay, thanks, Bill. I'm the D part of the panel discussion, design. So over the years, we have conducted and completed research that has been adopted by the FAA and implemented to try to prevent accidents caused by in-flight fire. So the approach that we have taken is really twofold. One is fire prevention, and second is rapid fire detection and extinguishment, or suppression until the airplane can be safely landed. So, in the cargo compartment, for example, we developed very stringent test method for the burn-through resistance of cargo liners. This ensures that the fire will be contained within the cargo compartment when it is suppressed. Also, The FAA retrofitted 3,500 airplanes with cargo compartment fire detection suppression system. ValueJet was a driver, but another driver was work that we did that showed that that type of halon system would prevent an aerosol can explosion during a suppressed fire due to the release of the flammable hydrocarbon propellants. In lavatories over the years, many changes have been made. Smoking was banned. Waste paper receptacle units were fire hardened. Automatic extinguishers are in the lavatory. And also there is a smoke detector. With regard to hidden fires, which is really the area that's of most direct interest to this discussion, we developed a very stringent flammability test method for the in-flight fire resistance of thermoacoustic insulation. If you look in hidden areas, it is lined with thermoacoustic insulation. So this went a very large way of preventing in-flight fires, where usually the insulation is the first item ignited, and it is the predominant material, as I said, in the hidden areas. In addition, during our testing, we discovered that one particular insulation material, which marginally met the then existent FAA standard, could be easily ignited with what we call a small ticking fault, or a very modest arc that would not trigger the circuit breaker. Because of that, 700 airplanes were retrofitted over a 5-year period. That was a significant effort because changing the insulation inside an airplane is no easy matter. In addition, FAA developed an advisory circular for in-flight firefighting. Most of you are probably familiar with it, 120-80. A lot of that was based on the experience we had from conducting tests and also our participation in accident and incident investigations. So that AC provides a lot of common sense information with regard to how you might be aware of the incidence of the existence of a hidden in-flight fire and what measures you can take. The importance of immediate and aggressive firefighting, that can't be overemphasized. The need to work together as a team, and the safety and effectiveness of halon, which is very important. With regard to halon, we required, since the mid-'80s, 2 halon extinguishers in aircraft, and almost all aircraft extinguishers are halon. Over the years, it's proven to be particularly effective against hidden fires. And I'll give you a good example of 2 specific incidents of in-flight fires in which one case halon was used and one case halon was not used. In Greensboro, 2000, DC-9 had an in-flight fire. It was a very severe fire caused by electrical panel failure right behind the cockpit. The crew never used the halon system, were afraid to use the halon because they had the notion that it might rob the oxygen out of the air. And consequently, was very fortunate that an airplane, which they did experience severe smoke in the cockpit, it occurred shortly after takeoff, and they were able to land very quickly. Similar event occurred later on that year here at National Airport. An MD-80 took off and was hit by lightning, and the fire erupted. It discharged a halon extinguisher, put the fire out, had emergency landing at Dulles, but the fire was put out. Incidentally, that airplane had the insulation that we found to be particularly prone to ignite resistance in-flight fire, particularly prone to ignition by a small ticking fault. So that airplane was either retired or the insulation was replaced. The other thing I want to mention about in-flight fires is that as we make efforts to make it more probable that the airplane can be landed, then the improvements that we've made over the years for post-crash fire survivability have a bearing. because these improvements really are primarily in the materials that are in the cabin to slow down the spread of the fire and give people more time to escape. And two in-flight fire accidents I can think of in which those improvements, had they been in place, might have made a large difference were Riyadh in 1980 and Air Canada in 1983. And just to close out, even though this is not directly related to the problem of smoke in the cockpit, I want to mention the work that people at the Tech Center did in our group, really sharp people, to develop a practical and cost-effective fuel tank inerting system. That was a major breakthrough. It enabled the FAA to issue a rule on fuel tank flammability reduction in 2008. And in addition, even before that rule was adopted, the Boeing company adapted that design and began installing those systems in their production airplanes. And I would estimate that between 1,500 and 2,000 systems to prevent fuel tank explosion have been installed in Boeing's airplanes. So that's a summary of, I would say, the major improvements that have been made to try to prevent in-flight fires over the years based on our research and the adoption of those products through rulemaking or advisory material into aviation. Thanks, Bill.
Thanks, Gus. To follow on with that, do you have maybe some information about what research in the near future and down the road might be in the pipeline to continue this effort to prevention?
Yeah, we have a lot of research going on with lithium battery fire safety. I'm not going to dwell on that, but we've learned an awful lot about the hazards of lithium batteries, and unfortunately, the more testing we do, the more concerned we are about these dangers, because just recently, for example, we've determined that the chemistry is not the only determinant of the behavior of the battery. It's also the design of the battery. So you can have a manufacturer with the same lithium battery chemistry in which the behavior of the battery can be totally different. But more relevant to the issue of cockpit smoke, we have work underway that will be completed next year, or work that we're going to initiate next year related to in-flight fire safety. We will be completing the development of improved flammability standards for aircraft ducting and electrical wiring. If you look into the hidden area of an airplane, beside the thermoacoustic insulation, this is particularly so in a standard or single-aisle airplane, the ducting and the wiring are very important elements in that small volume. So these are more stringent tests that we will be completing next year that will add an additional level of fire resistance if they are adopted, I should say. We also will be conducting tests that we will hope to complete next year with an on-board water spray zone fire suppression system for a Class E freighter cargo compartment. That's a very important piece of work. We're going to initiate a study that I think is very important, and that is to look at improved detection and sensors. And this is really in 4 areas. The first area is sensors that can eliminate the high degree of false alarms. This is a problem. We have false alarms that occur at very significantly higher rates than real fire detections. So that's a concern. We also want to look at technology that can discriminate between real fires and smoke and odor events that are non-fire related, such as from hydraulic leaks or oil leaks. These are much less hazardous, less of a risk to the airplane. We can develop the technology that can discriminate between those type of events. We want to also look at the sensors that can detect fires in hidden areas. and locate them. This is particularly important in small aircraft, the single-aisle airplane, where a portable extinguisher can be effective in the overhead. You have to know where the fire is. So that's very important. And also, we will look at other type of sensors, particularly in cargo compartments, because this is a problem. You have under development new technology that contains fires, whether it's fire containment covers or fire resistant containers. So you have a fire that's being suppressed, but the crew doesn't know about it because the conventional detectors are at the ceiling, and it takes the time it takes for them to activate is the time it takes for the smoke to get out. So we want to look at early detection. Early detection is important because it gives the crew more time to get the airplane down. And finally, we have a study that's underway. If any of you have followed, the research that we do, we present at our systems working group meetings. This is a study to look at all of the incidents of unenunciated smoke and fume events that occur, and also sensor activations. This is a monumental study, which is looking at data from aircraft emission data reports of the FAA, NTSB reports, and service difficulty reports. When I say it's monumental, it's probably in the neighborhood of 16,000 events. And that data is going to be tabulated in a data bank that has 24 different parameters, including things like, was it a real fire, was it a false alarm, where did it occur, what was the object involved, was there a diversion or a return, was there an emergency evacuation. We'll try to get a handle on the cost of these events. And this data bank will become completed next spring. It will be accessible to the general public. There will be a report that will analyze the trends and the significant findings. And I think it will give us a good idea of where the most fruitful direction we can go to try to reduce this problem the best we can. So that gives you a brief summary of some of the work that we have underway or will be completing in the near future.
One final question from me. I was curious because I participated in some work on the recent expanded use of PEDs on the aircraft. And now that we have that, of course, perhaps more and more of our customers are bringing their devices on board. And does it, in your opinion, has that elevated the potential risk for, I don't want to be harping on lithium batteries, but for fire and smoke events to occur on board the aircraft? Plus, the flight crew now has portable devices that they carry along.
I haven't particularly analyzed the data, but I wouldn't be surprised with the proliferation of portable electric devices that there will be more events. It's not just the PEDs, but Harry Webster showed a video of a tablet and fire. What can happen? There's increased use of tablets to replace the hardwired in-flight entertainment system. So these are all powered by lithium batteries, and beside the issues that have been well publicized with the main lithium batteries, aircraft lithium batteries, say in the 787, there are an awful lot of other aircraft lithium batteries. So anytime you have a lithium battery fire, it's a serious concern that demands immediate and proper action. And I think Mark mentioned this morning about the work that ICAO and IATA is doing to develop procedures for dealing with these fires. I'm not familiar with the details, but I think it's very important in developing these procedures that I hope they're being addressed. I'm fairly confident they're being addressed, that there are very distinct, different scenarios that present challenges to the crew. If you have a PED fire on a tray or on the floor, that's a lot easier than one that has slipped into a seat pouch, or one that's underneath a seat, or one that originates in a stow bin that's in a suitcase, in a bag, or underneath some other carry-ons. So very important to look at the different type of scenarios, because those scenarios will demand the action, or dictate the action that you take, and also the type of equipment that you could use to, effectively mitigate that particular problem. So hopefully these type of procedures will then translate into improved training and also improved airline operational procedures as well.
Thanks, Gus. Thanks, appreciate it. Captain Reed, maybe you can talk a little bit about the certification requirements. We were talking about smoke in the flight deck, and I mentioned earlier in the opening remarks, I think, a little bit about the guidance and material recommending smoke removal from a discontinuous source in a certain time frame. Perhaps you can talk a little bit more about that and how an OEM actually does testing to ensure the compliance with the regulation.
Thank you, Bill. One thing I want to say right off the bat is that we feel very much for our customers too when they lose an aircraft or lose crew members, because we are emotionally attached to our products, and they mean very much to us. Our customers mean very much to us. So it's very hard for us to see, as when David and I worked on UPS, to see an airplane laying in a field, or when we were in Korea pulling parts out of the ocean. So we take safety very, very seriously. As Boomer said, you all fly on our aircraft. Well, so do we, and we fly them every single week. We do the test flights, and we support our test pilots and our engineering test pilots, and safety, hands down, is our #1 objective. In a design program, we look at, and we kind of approach it from a couple different principles, and that is, one is prevention, and in prevention we're looking at the fact that we only select components to go on the aircraft that will not propagate fire, that we look at circuit breakers, and now smart circuit breakers, that will discontinue an ignition source, as well as identify an arcing situation. The other thing is that we approach prevention from a crew aspect also, that we use checklist in combination with system logic to evacuate smoke off the aircraft. So this has been a proven system over a number of years. Obviously, there are new products that our customers, are carrying on board the aircraft that are presenting challenges to all of us. We also design from a separation perspective, and that is that we, everywhere possible on the aircraft, we separate fuel, air, and ignition sources and route them in such ways that they will not interfere with each other or impact each other as much as possible. And the other one is isolation, that we, as Gus mentioned earlier, isolate smoke, fire in for example, a lower lobe fire compartment, for example. That we isolate, we design and prove that we can isolate that smoke and halon in that compartment, and that it doesn't migrate to another compartment in the aircraft. So we do that. We work that from an engineering standpoint, but we also design from the human standpoint too. And you probably remember the Swiss Air 111 accident. The FAA came out with AC 120-80 a little after that accident, which provided good guidance for cabin crews on how to manage an in-flight fire. But it lacked a little bit in the guidance that it provided for flight crews on how to manage an in-flight fire. So a couple of our PhD level engineers in Seattle, in flight deck design, checklist design, human factors, wrote a proposal, presented to the industry. The Flight Safety Foundation picked up that proposal, and we worked together with the industry. About 100 people involved in the working group, roughly, I believe it was a dozen on the steering committee on a smoke, fire, fumes checklist. And it was unique to the industry at that time because what it did was it approached the smoke, fire, fumes checklist template design from a accident and incident data perspective. In other words, the group got together and built checklists and built a template to build those checklists from that enabled manufacturers and airlines to go back and design their checklist based on industry data. So, for example, a pilot who's flying an Airbus, his smoke, fire, fumes checklist might address certain issues that are unique industry data on what is the most prevalent cause of smoke, fire, fumes events on that aircraft. Then he goes and let's say he or she upgrades to captain on a 7-3 in a few years. That smoke, fire, fumes checklist on that aircraft will look very similar, but it will be custom tailored based on industry data as to what causes smoke, fire, fumes most readily on that aircraft. So we approach it from an engineering standpoint, also from a human factor standpoint. To kind of dovetail on what Gus said, we also try to get out ahead of regulations, ahead of the industry, as quick and as fast as possible to bring new technology to the market as quickly as possible for the benefit of our customers, for the benefit of everybody who's flying on our aircraft. NGS was a perfect example, nitrogen generation system for inerting the center fuel tank. We changed the cargo liners in 1987. We discontinued Kapton wiring in 1993. And then, in addition, we are continuously evaluating the system logic that we use on board our aircraft as technology matures and grows. Perfect example of that is probably our 777 freighter, in that the 777 freighter ECS, Environmental Control System, system logic, in a fire main deck situation, non-normal procedure, where the system automatically, once it's initiated, shuts down one of the existing packs, one of the operating packs, to limit air to the fire zone, but keeps one pack operating for positive pressure on the flight deck to protect the flight crew. Well, the system logic has grown and the technology has grown such that these days now the 777 freighter ECS system, if that operating pack fails, can restart that shutdown pack to again provide protection for the flight crew. So we really try to get out ahead of the industry as much as possible, and we work not only internally within the Boeing company with some phenomenal engineers, but we also draw folks in from the industry, and we work together collaboratively. So it's a group effort. There were just, I think the last one was 2 weeks ago. We had an internal initiative going on with one of our customers on in-flight fires, and that work continues on an ongoing basis. So it continues on much longer after the initial design phase of the aircraft, but in fact continues on for the life of the model. So.
Thanks. Yeah, go ahead.
To piggyback on what Bill was saying, I was part of that committee that did the smoke, fire, and fumes thing, and had it not been for Boeing leading the way, we wouldn't have had that checklist come out. Now, we had other participants in there, Airbus was there, and some of the other carriers, but they sent Bill McKenzie down, and the fact that Boeing was on board, Flight Safety Foundation picked up on that, and we got that done. So had it not been for you guys, that checklist probably wouldn't have come out and been so well accepted. When the checklist did come out, it wasn't just eyewash. Boeing jumped on it. Every one of their fleets was modified with the new checklist. So give you a little more credit, you take it on that. You guys really led the way on that, and I don't think it would have gotten done had you guys not been so out front and helping us with it.
And we appreciate that. I think the hat really goes off to Bill McKenzie, Barbara Holder, really did some phenomenal work, bringing in the right people within the industry to have a coalition of industry experts attack this issue. And that's the way we like to work. We like to work with the industry because the product in the end is much more superior. So one thing also to dovetail on what Boomer said earlier, some of the challenges we face. We as pilots, and I've been in this industry not nearly as long as some folks, but I'm up there in double digits, Gus.
He's talking about you, Gus.
But the fact that we work very much with the industry to try to solve problems, and it used to be, for example, a quote-unquote barroom haze was what we were able to certify to. And now we have to certify to just a wisp of smoke that extinguishes immediately. So give credit to the FAA. They're not always the bad guys. They do set pretty stringent standards. We try to exceed those whenever possible. So.
Thanks, Bill. I'm going to circle back a little bit, and we talked about it in the ready room actually a little bit when I was coming back to the autopilot on the UPS-6, and this is not intended to imply any dinging on anybody, but I just found it really interesting when I read the report, and maybe you guys anybody could chime in on the thought, but it was amazing to me. We talked about the beginning of the loss of flight control because of the heat impacting the cables underneath or over the top of the main deck. And as pilots, at least for me, you know, you're taught that if the automation's not behaving expectedly, turn it off and fly the airplane. And just have to keep in mind that if I can't fly the airplane under manual control, don't forget you have the automation. In the airplane involved, that particular design, it's not the case everywhere, of course, but that particular design, the autopilot servos are back in the tail. And even though you might not have a connection with the control column to the flight controls, the autopilot servers are still there. The problem, of course, is the cockpit was full of smoke, so how could you see the dial in the stuff on the autopilot? But I just thought that was from an operational point of view as a pilot, it's something to keep in my mind, and I throw that out to you all, that, you know, even we advertise for maintenance of manual flying skills, absolutely, but don't forget all the tools available to you. I guess that's an obvious statement, but I found that very interesting. I didn't know if you all had any kind of comment on that or with respect to the autopilot.
Just addressing it, and probably from a human factors standpoint, and that is that in very similar to the A380 accident, or not accident, but incident they had where had an uncontained engine failure and tore out some of the hydraulic systems on the 380. Very interesting to listen to that crew and how they handled that emergency. They had so many messages coming at them that it was hard to process what was going on with the aircraft. They reversed the psychology. Instead of looking at what is not working, they started to look at what do we have that is still here? What is still working? From a human factor standpoint, exactly. UPS-6 crew, take my hat off to them. They did a very good job with what they were facing. They found that the flight controls were not working the way they expected them to, so they went back to what was previously working. And they were able to keep that aircraft airborne for 22 more minutes. So use what is working sometimes and approach it from that angle.
Thanks, Bill. I want to give a plug for our Master Minimum Equipment List project within AD02, because we talked about some of the supplemental type certificate, the aftermarket systems that may be out there to help the crew see to land. And one of the things, if any of the developers are in the audience to consider, is MMEL, Master Minimum Equipment List relief. You have a potential, without that relief, you have the potential to have an optional piece of equipment, safety equipment in this case, optional, that an operator could install on their own if they so choose, but without a relief for the times when that system might be inoperative, it immediately grounds the airplane. So it provides less incentive for that operator to adopt that equipment. So thanks to our MMEL team working with the Flight Ops Engineering Board and Evaluation Board and the industry group and coming out with a policy letter 109. So it's just a shout out to the developers that may be out there. Just remember policy letter 109, and when you're seeking FAA certification, don't forget to include that in your package.
If in the next couple of days you so happenly come across a demonstration of an enhanced vision device somewhere around, try it. It'll make a believer out of you. It made me a believer the first time. It's pretty unique. So I don't know if there's one out there or not, but if there is, bump into it, try it, you'll be a believer.
Yeah, and then think about the things, you know, when you ever simulate anything, you don't get the full picture. Of course, you got to put yourself in the situation of the airplane. I mean, any of these systems, you're protected in your vision. Can you read a checklist? Can you, think about those operational things when you go out and play with that equipment and learn about it. I'm going to open this up for questions soon, just in a moment, but I wanted to just kind of recap a little bit. I mean, we talked a little bit about the Flight Safety Foundation checklist template, emergency equipment access, improved materials, ALPA policy, technologies for detection, monitoring, and suppressing in-flight fire in accessible areas, some lessons learned from recent accidents, current certification requirements, future R&D efforts, MEL relief, manual control issues, and issues with tablet devices, and then for open it up, just say again, this is a team effort, manufacturers, regulators, and us. And I ask both the manufacturers and the regulators, don't forget us. Give us the tools to handle these situations. And so with that, I want to go ahead and open it up to the floor for questions for the panelists. And if you would, we got mics in the aisle, and please give us your name. And
thank you very much. Great presentation, John Teely. And I'm interested in finding out about aging aircraft. And Gus, I've been really impressed by that which you've presented. And I'm wondering if maybe you might speak directly to this or others in the panel as well, since you all have experience in this area. But when we have aging aircraft and certification, are there breaks in the system where we say, okay, this aircraft, which was certified before this date, is fine, we'll keep it that way and it can continue in service. And then, but all other aircraft of that, maybe even that same model, are now upgraded to maybe the insulation, some other component within the aircraft. And how does that fit with current Fed policy as far as continued operation in 121 service or 135 service and so forth? Thanks.
Well, usually if there's an improvement made that is considered for implementation, there's basically three ways you can implement it. You can implement it as a new type certificate requirement. You can implement it in production airplanes, or you can retrofit. And usually the factor that determines which way you go is cost. Because, as we all know, even though most people don't like it, everything has to be done on a cost-benefit analysis. It's an executive order. It's been in existence for over 30 years. And technology that we have implemented, some has been just new type certificates, other has been in production airplanes, and other has been retrofitted. The fuel tank and earning rule, there were in-service airplanes, 2,700 that would have to be retrofitted, and an additional 2,300 in future operations. With the insulation, it was in production airplanes. 700 were retrofitted because we discovered there was a particular type of insulation that was unacceptably prone to ignition. So I'll just give you some examples of the thought processes that go through, but again, sometimes it's retrofitted, sometimes it's new production airplanes, and other times it's only new type certificate airplanes that these improvements are made.
And part of that equation is identifying with an aging aircraft, it's not just aging aircraft, it's okay, if you were to prioritize, what certain things within that aging aircraft are the most bang for the buck? If it's, you know, wiring insulation, if it's blankets, those things have to be identified first as well.
Mm-hmm.
Okay, thank you. Dennis, I think. I wasn't looking, so who you guys can duke it out, I don't know.
Yeah, Tom Dunapace, a United pilot.
Hi, Tom.
I just wanted to make a comment on aircraft I've flown that have had the smoke goggles separate from the oxygen mask. It seems like the second step in all the smoke, fume, fire checklists is goggles if required. And by definition, if you have to have the mask on for fire, fumes, or smoke, you have to have the goggles on. And it should just be automatic, because if your eyes aren't poisoned yet, it could be moments later when you won't be able to get the goggles on.
That came up when we wrote the, excuse me, the original template, and there was a lot of argument about that. That if you have smoke in the back of the aircraft, the flight attendant say, hey, we got smoke in the galley, would you put your oxygen mask and goggles on? You know, probably not. So the one side that said was, we don't want to restrict the pilots, because when you put that quick face mask and goggles, whatever, it's very cumbersome, and we talked about having communication problems and all that. The other side said, you know, there are toxins in the air that are odorless, colorless, and tasteless, and if you inhale it, you know, you're dead. We fought the good fight on that one. I would have made it mandatory. We compromised for the, you know, the sake of getting a checklist out to say as required, to leave it up to the crew's determination to do it.
Well, hopefully it won't be that long before we have all full face mask
exactly right.
equipment. But in combination with that, and I know from experience, when you're trying to work the communications, and you've got all this on, and you know, they're all different, and you're talking to air traffic, and you're talking, and you mix it up. And next thing, you're reading the checklist and ATC, and finally someone made a comment I thought made a lot of sense, is just forget about it. Do the checklist and everything on ATC.
Yeah. But that was a good point you brought up during the thing. We found the same thing, that, boy, you put these guys with the mask and goggles on and just don't, you know, pencil whip it, let them do it. Oh yeah, they're talking to ATC, they're talking through the back, they're saying stuff that you want to hear. You know, I mean, it's really, you do need to practice that. And Bill said the same thing. When the guy goes out, takes it, you know, goes to the break, put that thing on and try it right then. That's the time. It's the time you want to do it. I've had smoke in the cockpit myself, and that's not the time you want to be thinking about what switch was that. That was a good point.
And Tom, just to comment on your question, great question. Mm-hmm. One thing that we find as a manufacturer is that the two-piece oxygen mask still does meet certification requirements. We all have a like or dislike for that mask goggle combination. 787 is gone to full face mask. One thing I encourage you to do, and I encourage all operators to do, is if you have a preference on full face mask, run it through your safety department, run it through your airline management, and tell them that you want it. It's airlines that are choosing that system, and what we find is oftentimes they choose and select, even on newer models that they are taking delivery on, continuation with 7.3 NGs, for example, they will choose the two-piece mask even though the full face is available because of legacy fleets they have that have the two-piece. So for cost savings, for saving on maintenance costs and things like that, they want to continue with the same equipment they have on previous models, even though the full face is available. So I encourage you to work through your safety departments, work through your airline organizations. If you believe the full face mask is what you want and what is best for your crews, request it. But you have to work that up through your management.
Bill's right. After Swiss Air, one of the results was that we used to have the Dixie Cup mask with Delta. Mm-hmm. And Delta on their own basically said, nope, we're going full face masks, and you're right. We went forward, so that's what we wanted, and the company right. said, yeah, and we did it. So no regulator had to tell us to do that one. We just did it on our own.
Dennis?
Well, I have a couple of things. First, Boomer, nice tie, dude. I like that. Mr. Sarkos, with regard to these lithium battery and tablet devices and things, now that we're seeing all of the operators introducing tablet devices up into the cockpit. Is there any data that you've got or a way that you can collect this data as it develops for the difficulties on this? And where I'm going is, are you able to get to company ASAP reports? You know, pilots fill out an ASAP, but we don't fill out an ASR to the NASA system anymore. And I'm wondering if your data collection efforts that you mentioned are including access to the company submitted ASAP reports that all of these pilot organizations are using.
As far as the study that I mentioned that's being conducted on the in-flight smoke incidents, there's 3 sources of data. There's the FAA Aircraft and Accident Data System. There's a service difficulty report, which is a requirement that you have to fill out that report, and it's the NTSB accident data. So I'm not sure if the ASAP material would be redundant with the service difficulty reports or not. I'm not that familiar with the data.
Well, Trish DeMacy back here is the Delta Airlines ASAP guru. Trish, can we get, I'm an ASAP guy myself, can we get ASAP data to the FAA on something like that for his, if we have tablet, you know, any kind of smoke thing? Is that something we can pass on to these guys?
I think it's passed on for company reports, but not the ASAP reports.
Okay.
Yeah, the other piece of that is, you know, I come to understand earlier today too, is that, well, with ASAP in particular, I mean, sometimes these are events that are reported, there are events reported that don't go anywhere else.
Right.
I don't know if they show up in the standard databases. And in particular, I guess with the NTSB reporting, smoke is not on the list. Fire is, but not smoke. So,
And that's where I'm going. These, I kind of consider the ASAP program to be a dead letter box as far as many of these events getting into the larger reporting system. All right. Well,
au contraire, I would suggest you talk to Trish about that. If you want data, I'm sure, depending on the circumstance, it's available for anybody. But I can't speak for the ASAP program.
Or it doesn't.
My boss is cringing back there. Sorry, boss.
Okay. And Dave, you are absolutely spot on about the oxygen mask thing. I would say that I've become somewhat of a pain in the neck for most of my first officers when I insist without any doubt that you're going to wear that mask when I leave the cockpit. And the difficulties that you speak of are all the same things that go on. I can tell if a guy knows how to work his mask by whether he can get it back in the box after he gets done with it. So, and I don't want to go into old war stories, but that's an important.
it's a rite of passage,
aspect.
right? If you can get the thing back in the box, you get dinner.
All right. And as you're designing these things, Bill, if you can find a way that they can get them back in the box easier, that might actually make the industry use them.
Believe me.
Well, and that's a really good point, I think, because some people don't do that because they go, this is a pain in the butt to put back in the box.
It is, and Dennis, thank you, because that's a point that I wanted to address here when some of the questions were done. As what Boomer said earlier, is that sometimes we as pilots look at the oxygen mask and we talk about the length of the hose, we talk about getting the mask back into the box. I'm amazed sometimes at the constraints that a manufacturer is under. Regulatory, you can imagine some of the regulatory constraints that we have on us. How hard it is sometimes to make changes and get them approved. And it does take a period of time. One thing we are running with, problem we're running into with the 7.3, for example, is we would like to extend the length of the hose. But what we run into is the constraints of the box itself. So the oxygen ARs talk to the development group, let's say for the new 7.3, and look at the fact that, well, we want to lengthen the hose X amount. But you run into structures folks that say, we're out of room. The box is within 1/8 of an inch of structure that we can't move. There are some incredible constraints that you don't think about from the pilot seat when we think about, well, we would just like to extend the hose X number of feet. It brings in all these different engineering systems into sometimes making very small changes. So it's not always as easy as we all hope it would be. Thank you.
Thank you. I see we have I see we got a text question available.
Whoa,
so,
no way.
Yes. I feel
Wait a
really
minute, my wife's
like
out there. Are you on the phone?
Feel very so who's ever in charge of the text questions, can you read the question?
Sure. This is for Captain Reed. Captain Bombardi mentioned the smoke displacement system. EVAS is one of those. And do the manufacturers have any concerns with the installation of those systems, and how does the manufacturer interact with those vendors to put those on the airplane?
We do. We have looked at vision enhancement systems, and we continue to look at them today. One thing that we are very conscious of is unintended consequences sometimes. And we have looked at different manufacturers, different products out there, and have found that even though they may provide a good resource for seeing visually outside the aircraft, oftentimes it misses a lot of equipment that concerns us in the cockpit. The center DU, standby instruments, comm panels, things like that. Also, one thing we have to be very careful of as a manufacturer is that just like in our manuals, we write manuals and we put equipment on board our aircraft, not just for our US market, but we are a global company. And we have customers and users, meaning pilots, flight attendants, mechanics, where English is not their first language, not their primary language. So we are extremely careful and do a lot of due diligence in writing our manuals. We're also very careful in the equipment we put on board the aircraft, because many times some of our customers will look at that and say, well, if Boeing puts it on the airplane, then it's the end all. It is the one-stop shopping answer to all our problems. And we have to be very, very careful of that. Also, our operators run different operations. The different way they run their cockpits, different way they run procedures. And we feel that it's better off for the individual operator to evaluate, what does my pilot group feel is the best thing for us? What is the best, given the procedures that we use, what is the best vision enhancement system for our needs and our operation? And we will go with that. So we don't want to dictate to you what you should use, but we want to give you the flexibility to use what you believe is best for your operation in your unique situations.
Thanks, Bill.
Hi, Ken Plunkett, Delta Airlines. Another EFB question, because I'm going to have my lithium battery explosion device attached to the window right next to me here.
What was it? No, it was a term of something about something in disassembly on the
Disassembly, not explosion.
So,
use that
Catastrophic disassembly.
that device should be submerged or just doused with water. That's kind of hard to do up there. It's also a smoke generating device. So how about if we, first step is get it off the cockpit. Of course, at 700 degrees, that might be a little challenging to do. I mean, we're introducing commercial off-the-shelf devices with not a lot of background stuff, and I'm sticking them this far from my face and my crew's face. We got 2 of them, 3, sometimes 4 on the airplane. Airlines are writing procedures now. You know, do not move the device, douse it with water. They're all great paper things, but if I do burn my hands, I'm getting that smoke generator out of the cockpit. It's somebody else's problem, so I can look out the windows. I mean, this stuff needs to be gone over and over. And, you know, Bill and I, we're going to talk about some other options here. And I'd love to be able to stop by in Atlantic City to talk to some of you folks too. But I'm looking for ideas here, so it's not going to end here. So any thoughts or comments you have, I'd love to hear.
Okay. These tablets are being introduced now as EFBs. Some of them are magnesium, I've been told. There are new magnesium alloys that are very fire resistant. So magnesium is not magnesium, is not magnesium. So if there's a choice that you can make, use a fire-resistant magnesium. If you don't want to use magnesium, use another type of material. So there's choices that you can make with regard to the tablet composition. In the event of an actual tablet fire in the cockpit, the first thing you should do is put it out with the halon. The halon's safe, you want to put the fire out. The second thing is you want to get out of the cockpit immediately. And then the cabin crew should deal with it. And when the cabin crew deals with it, if it's simmering, then they should just pour water on it or discharge water on it. We can't, normally the procedures that we recommended were based on tests that we did with laptops, and they were meant for the cabin. We didn't address the cockpit. And the procedure is to extinguish and to cool. You can't cool, you don't want to spread water in the cockpit, just like your concerns you raise. So you want to get it out of the cockpit as quick as possible. The more likely scenario that you're going to have is a scenario in which it's getting hot or it's starting to smell or it's smoking. And in that situation, you want to get it out immediately because there's no flame. You don't have to discharge any halon. So you want to get it out. The other thing that I would suggest to the operators is that they should look at, because I don't know much about the details of these tablets in the cockpit, but you look at how they're secured in some type of mounting fixture and how they're docked with the airplane. And however that's done, there should be means for quick dismounting and quick, removal from the docking system. So those are the type of things that, the type of advice I can give you right now, just based on the work that we've done in the past and from my scarce knowledge of, what these systems are in the cockpit.
Thank you very much. I appreciate it.
And it is a challenge. I was going to say it is a challenge because it's one thing when you have avionics that meet a certain standard, DO 160 or something like that. When we talk about commercial off the shelf, I would almost have to say impossible to dictate to certain or to any of the consumer electronics folks of this is what we want you to use for your alloy to build your cases. I mean, maybe they can hear this and hear our sensitivity and say, hey, this might be good for the whole customer base too, and we'll get there that way. But it is a challenge that we're using commercial off-the-shelf stuff.
Definitely stop in and see Gus. If any of you guys get down to the Atlantic City Tech Center, I've been down here a couple of times. I tell you, it's something to see. Had I not been a pilot, I'd be working for Gus Sarkos, man. These guys get paid for setting things on fire. I mean, it's just,
I might also add that because of this concern, we just recently bought a number of tablets of different manufacturers with magnesium, and within the next few months after we receive these things, we'll be running some tests. Nice. One thing about the tablet that's a little bit different from the laptop, in a laptop, the batteries are the cylindrical types, and those type of batteries have a propensity to propagate a lot quicker than in a pad where you might have a lithium polymer cell. So the rapidity of propagation may not be as significant, and maybe there would be less reluctance of picking it up. Somehow you're going to have to pick it up, and whatever protective means are available, use them. But in the end, the thing in mind is that, at least in my mind, the risk of picking up something like that in the cockpit is much less than the risk of allowing that to propagate in the cockpit. That's probably one of the worst scenarios that we can think of in terms of a lithium battery fire.
Thank you, Gus. It looks like our time up here is coming to a close. So I first off want to say it's been a very interesting and lively discussion on a topic that the ALPA pilots are very keen about. So I do want to thank all of our panelists for their insights and thank our audience for great questions. Indeed, the work is not finished, and I'm hopeful we'll see further improvements towards achievement of ALPA's policies regarding smoke, fire, and fumes. So I think we're, Chuck's standing in the wings there. Please don't forget to fill out your critiques, and thank you very much. Thanks to our panelists.